Kia ora, here's another video from Scholarship Calculus 2019. So just another small one. This is question 2a, and it's a surd equation. And we're asked to figure out, in this equation, k is a real number constant, and we have to find out when will the equation have imaginary roots. So for what values of k will the roots be imaginary? So as soon as you see that, you should be thinking quadratic formula and looking at the discriminant. So this question, again, there are a couple of ways to do it. Have a look first and think that you could either square both sides, which is going to get into quite a mess, or you could just do year 9 fractions on this. And the simplest way to do that is just to rewrite it like this, as root x minus 2 over root x. Oh, why is it doing that? Minus root x over root x minus 2 equals k over 4. So as usual, when we've got fractions and we're subtracting, we're going to find a common denominator. So let's do that now. The common denominator will be root x minus 2, and some very nice things happen when we start to multiply in the other term. We get x minus 2 here minus x for this times this equals k over 4. So that gives us very easily negative 2 is equal to k over 4 times root x times x minus 2, right? So I'm multiplying both sides by this, and then I'm chucking them under 1/3 sign, because remember root a, root b is the same as root ab. So where have we got to? Well, we're just about there, right? We've got negative 8 is equal to k root x times x minus 2. So we're back at, I guess, about a merit level 3 complex numbers problem. 64 is equal to k squared times x squared minus 2x. So we've got a nice little quadratic. Let's just expand it and figure out a, b, and c. We've got k squared x squared plus 2k squared x plus, whoops, not plus, minus 64. And that was close. That was nearly a disaster. Right, now a, b, and c. Here they are, k squared, 2k squared, and negative 64. So for imaginary roots, we need to have b squared minus 4ac is strictly negative. So b squared minus 4ac is equal to 2k squared squared minus 4 times k squared times negative 64, and that's got to be negative. So 4k to the power of 4 plus, I'll just leave that as 4 times 64k squared is strictly negative. I can divide through by the 4, and that gives me k squared into k squared plus 64. So you probably don't need to do this step, but I think it's more elegant. It's that. So k squared is greater than 0, and so is k squared plus 64 for all k real numbers. So the answer here is no values of k will give imaginary roots. So there you go. Pretty straightforward. Do give it a go doing it the other way, and I think, because I think it's useful to see what not to do. If you square both sides here, you will get there, but you're just going to have more work, right? So you're going to have x minus 2 over, what are we going to have? X minus 2 over x plus x over x minus 2, and then you get a reasonably nice term here because you get minus 2 times, that works out to be root 1. So it looks like you're getting somewhere, and you are, but you're not getting there as fast as the way that I've done it, which is also the way that they did it in the schedule. So there you go. Shortest scholarship calculus video on record. Let me know if you've got any questions.